Welcome to this explainer. I am absolutely thrilled you're here today. We are taking a massive leap. We're moving way beyond just unboxing pre-built drones, and we are stepping directly into the role of the drone architect. As your instructor, my goal is to help you build a really deep, intuitive mental model of exactly how these incredible machines work, literally from the ground up. By the end of our time together, you won't just recognize the parts of a drone, you'll understand the core engineering logic behind exactly why they are chosen. So let's dive into this. Here is our roadmap for today. We'll start with the big picture, do some anatomy mapping, dig into the airframe foundation, walk through a practical maker beam build, and wrap it all up with the builder mindset.
All right, Section 1, the big picture and anatomy. Let's establish our core philosophy.
You know, when most folks hear the word drone, they instantly picture a quadcopter hovering in the sky. And yeah, unmanned aerial vehicles absolutely dominate the skies. But true custom drone building spans all terrains. We've got ROVs exploring underwater depths and rovers navigating rugged land. Our core philosophy today is that true control, whether you're up in the air, deep in the water, or rolling on the ground, only comes from understanding the underlying technology. You can't truly master a machine until you know how to build it yourself.
Okay, so every drone is basically a giant puzzle of interconnected systems. And interconnected is absolutely the key word here. Building a drone is a total masterclass in cause and effect. If you choose a heavy airframe, well, that decision cascades through the entire machine. A heavier frame means you're going to need larger motors and bigger propellers just to generate enough thrust. Bigger motors, they require higher capacity electronic speed controllers, or ESCs, and all of that requires a much larger, heavier battery pack, which, ironically, adds even more weight. Understanding this delicate balancing act is exactly what separates a novice from a true architect.
Let's jump into Section 2, a deep dive into the airframe foundation.
Think of the airframe as the skeleton of your drone. Its job is surprisingly simple. Hold everything together and, don't break under the intense physical stresses of flight. The beautiful engineering reality here is that pretty much any material that's reasonably rigid, strong, and lightweight can serve as a highly successful chassis. People have built functional quadcopters out of everything from ultra-expensive custom carbon fiber right down to simple wooden dowels.
When it comes to sourcing your airframe, you generally have two paths: commercial kits or custom DIY builds. Commercial kits are great. They offer a super polished appearance and effortless compatibility. The manufacturer has already done all the math to ensure the motors perfectly fit the mounting holes. But building your own, whether you're 3D printing custom parts or cutting out a wood frame, gives you the ultimate flexibility. You are designing it specifically for your exact mission parameters.
Consider two very different real-world examples that illustrate these trade-offs perfectly. On one side, you have something like the Parallax Elevate kit. It features these sleek aluminum booms and exact plastic mounting lugs. It's absolutely beautiful, but it's rigid in its design. Everything fits perfectly right out of the box, but that's about it. Contrast that with something like the Flown, which is basically a laser-cut wooden puzzle frame. It might not look like aerospace tech, but its adaptable nature is just incredible. If you need to mount a brand new sensor, you don't have to hunt down a specialized bracket. You just grab a drill and make a hole right in the wood.
As you evaluate any airframe, you're constantly playing a game of tug-of-war with a few key criteria. The biggest battle for sure is strength versus weight. Let me give you a slightly harsh warning right now. Building a massive, indestructible tank-like chassis is completely useless if your motors lack the thrust to actually lift it off the ground. It's just a paperweight. You also have to factor in the dimensions based on your specific propellers and how easily you can actually mount your hardware.
Moving on to Section 3, Practical Translation. Let's look at the maker beam build.
This right here is exactly the kind of target we're aiming for. It's a custom, open-source aluminum chassis built from modular maker beam girders. This kind of setup is just fantastic for prototyping because it perfectly balances that vital rigidity-to-weight ratio we just talked about, all while giving us nearly infinite options for mounting our components.
The assembly process is all about building subcomponents. We start by creating 4 identical modular arms. Now, why 4 identical arms instead of just one solid, continuous piece? Well, because if you crash and bend one arm, you only have to rebuild that single small section, not the entire frame. Once those 4 arms are built and joined at the center with brackets, we cap the whole thing off by attaching a specialized platform just for our electronics.
What's really interesting about this specific system is the connection method. The heads of those M3 screws are actually square, and they slide directly into the channels extruded into the aluminum beams. This is a huge deal because it means you aren't limited by pre-drilled holes. You can slide your hardware to the exact millimeter you need, then just lock it down with a right angle bracket and a bolt. It creates a highly adjustable, incredibly secure geometry.
Finally, we top off our rigid metal structure with a 3mm thick piece of Baltic birch wood. You might be wondering, wait, why put wood on top of a metal frame? It's actually a very deliberate, super practical engineering choice. Wood is phenomenally easy to modify on the fly. When it's time to mount your delicate flight controller, your receiver, and that heavy battery pack, you can just measure and drill custom holes directly into the wood in seconds. You get the rugged strength of metal combined with the ultimate customization of wood.
All right, let's wrap things up in Section 4, the builder mindset. Let's lock in that engineering mentality.
I love this quote straight from our source material, and it is the absolute, unfiltered truth. The dirty secret of quadcopters is that they crash a lot. Batteries die unexpectedly, a random gust of wind catches you, or a tiny technical glitch sends you plowing straight into the turf. It happens to everyone. Therefore, you absolutely must design and build with crashing in mind. You have to prioritize modularity and rapid, easy repairs over just making a drone look cool. A beautiful drone that takes 3 weeks to repair is, quite frankly, a bad design.
So let's reinforce our mental model here. Remember that cascade effect we talked about earlier? Every single component you add, every heavier bolt or bigger battery drastically affects your weight-to-thrust ratio. So choose your materials wisely. Embrace modularity, like those 4 identical maker beam arms, so you can swap out broken parts in minutes. And hey, don't be afraid to mix materials, like using that wooden top plate to give yourself an easy path for on-the-fly modifications as your drone evolves over time.
You now have the foundational knowledge. You understand the interconnected systems, the critical importance of the airframe, the trade-offs of different materials, and the harsh reality of designing for the inevitable crash. The tools are literally in your hands now. So I'll leave you with this. Applying your brand new builder mindset, what will your first custom drone be built to do? Will it dominate the skies, map the ocean floor, or navigate the rugged earth? The design is entirely up to you. Thanks for joining me on this explainer, and happy building!